So this is the 2020 Higher Level Leaving Cert Maths Paper 2, question 4. So you've got to find the two values of theta for which tan of theta over 2 is equal to minus 1 over root 3 and theta is between 0 and 4 pi. Okay, so let's just have a look at this here first, this 1 over root 3. The tan of something is going to give us minus 1 over root 3. But let's have a look at 1 over root 3. First of all, so if we take our axis, x and y axis, and we look at 1 over root 3, so the tan of what will give us 1 over root 3? So the tan of pi over 6 will give us 1 over root 3. So we know that the tan of pi over 6 will give us 1 over root 3. So our reference angle is going to be pi over 6. Now we want to get the tan of our reference angle so that we end up with a minus 1 over root 3. So we've got to see where is tan negative. And tan is going to be negative in the second quadrant and the fourth quadrant. So these two quadrants here. So in other words, that's where our reference angle is going to be. So if we take, let's say, this angle here, and we'll come down this direction as well. So we'll take pi over 6 as our reference angle here, and pi over 6 as our reference angle here. Now, there are reference angles, so what we really need is our actual angle as measured from the positive direction of the x-axis. So what we're going to do is look at this angle here. Well, let's just call it what it is. It's going to be 5 pi over 6. 5 pi over 6. Because this is pi out as far as here. And that's going to be 6 pi over 6, which is just pi. We are going back 1, so this is actually 5 pi over 6. So let's look at our second angle then. So let's look at the angle that goes from here all the way around to here. Well, if we come all the way around to 0 again, that's actually going to be 2 pi, which is actually 12 pi over 6. 12 pi over 6 is just 2 pi. We are coming back 1 pi over 6, so really that's going to be 11 pi over 6. So this angle here is 11 pi over 6. So there are two angles whose tan is minus 1 over root 3. So in other words, if we have tan theta over 2 is equal to minus 1 over root 3, that would mean then that theta over 2 is going to be equal to 5 pi over 6, or theta over 2 is going to be equal to 11 pi over 6. Now, because we're going to be looking at angles bigger than 2 pi, we're going to add in 2n pi here and 2n pi here. Okay, so let's just see if we can work out theta from this. Now, we have theta over 2 is equal to 5 pi over 6 plus 2n pi. Let's multiply across by 2 to find out what theta is. So that'll give us 10 pi over 6 plus 4n pi. Or here we'll have theta is equal to, if we multiply across by 2, we'll get 22 pi over 6 plus 4n pi. Now we can simplify these angles. We've got theta is equal to 5 pi over 3. So this should be a plus here. Plus 4n pi. And we have theta here is equal to 11 pi over 3 plus 4n pi. If n was 0, that would give us theta is equal to 5 pi over 3, and if we put 0 in here, we'll just get 0. Or theta is equal to 11 pi over 3. Again, we put 0 in here, that'll give us 0 there. Okay, so if we put 1 in here instead of n, we'd end up adding a plus 4 pi, and that's going to bring us outside the range of values that we were allowed initially. Theta must be between 0 and 4 pi. So these are our two answers anyway. Theta is 5 pi over 3 and 11 pi over 3. Okay, so let's look at part 2 then. We have a diagram and it shows OAB, a sector of a circle of radius 7 centimeters with center O. The angle BOA is equal to 1.2 radians. The area of the shaded region is 21 square centimeters, so this is 21 centimeters squared here. Find BC, so we've got to find this distance here. Give your answer correct to one decimal place. So I'm going to look at areas here. I'm going to look at working out the entire area of the area of the entire sector here, shaded and non-shaded region. Then I'm going to subtract the shaded region here to give me the area of this region here. And using half AB sine C, I'll be able to work out what OC is, and then just subtract it from 7 to give me BC. That's the plan anyway. So let's see how that goes. So the area of a sector, when we're dealing in radians, is half r squared theta. In this particular case, it's going to be half times our radius is 7 squared, and then our angle is 1.2 radians. If we work that out, we get 29.4, and this is centimeters squared. So that's the area of our entire sector here. Given that, then what we can do is find the area of the white region here. So what I'm going to do is just subtract 21 centimeters from that. So the area of the white region is going to be 29.4 minus 21, so that gives us 8.4 centimeters squared. Now this white region here is a triangle, so what I'm going to do is use the formula half AB sine C. So we know that the area of the triangle is half AB sine C. So the area of our triangle is 8.4 units. So we have half, and if we look at our triangle, then we have one side here which is 7, and the other side which is OC. So it's 7 times OC. So we want to multiply it by 7, and the distance from O to C. So it's half AB and then sine of 1.2. Okay, so next thing we can do is just get OC on its own here, if you like. So what I'm going to do is, let's see, we'll multiply across by 2 first. So that's 16.8 here, and then on this side we've got 7 times OC times sine 1.2. So now let's just divide across by what's remaining. So we have 16.8, and we're going to divide by 7 times sine 1.2, and that'll give us the distance OC. So the distance OC is going to be 2.574999,307. Okay, so the distance that we've actually found here is this distance here. We're asked in the question to find BC, so all we've got to do is subtract it from 7. So the distance BC is equal to 7 minus 2.574999,307. So that will finally give us 4.4 to 1 decimal place. We're asked to find the distance BC to 1 decimal place. And that's it for this question.